So, good afternoon, everybody. I'm Pierre Gelpi from Semtech, and I will be moderating this panel. Welcome to the asset tracking panel of this event. Actually, the exact title is Using LoRaWAN and GS1 Standards for Asset Tracking. You will understand why. Before I introduce the speakers and the panelists, I need to wake you up after lunch, so let me just ask you one question by raise of hands. Who came to this event by car? Okay, nobody, so you were right. Who came by train? Okay, some of you, probably the others had plane and train combined, and that's the good choice because you had less delay, right? You arrived on time because if you use the car, it's more complex. Anyway, that is just to introduce the topic by this angle. So even if train is better, you have less. It can still be improved, right? The delay is still too much with the train. And actually, it's very easy to improve, or at least the figures show that it's very easy to improve because only 30% of the reasons for delay are external. 70% of the reasons for delay are somehow technical, right? Linked to infrastructure or linked to traffic management or linked to rolling stock issues. So it's related to somehow maintenance or management of technical issues. So with more traceability, it can be improved. Of course, asset tracking and logistics is not only about railway. The main challenges of asset tracking in general are the following. The first one is the loss of perishable food and pharmaceuticals. For instance, losing a container full of fresh food in the middle of the sea, or we've seen that with vaccines as well. The speakers will come back to that later on with a very concrete use case. The second challenge is unauthorized use of returnable assets, either pallets or racks in the industry, for instance, auto or aviation industry. This is a very, very strong challenge, and actually it can be solved only with, for instance, automated inventory, reducing the cost of replacement, right? The replacement cost of these returnable assets. And the third one is a theft of high-value goods, both for retail and in the industry in this case. So let me show you now a high-level view of the logistics chain, starting from the left with the factories that are producing goods, and up to the right where you have the retail, right, to simplify. And in between you have local transport to distribution centers or warehouses. You have long-distance transport that can be done either by plane, by boat, or by train, sometimes by truck as well. And then last mile distribution, most of the time also by truck, right? And depending on the segment of this logistic chain, there is a combination of technologies or standards that are relevant. For instance, having a LoRaWAN coverage in a warehouse is very easy, as you know. The goods are usually identified with GS1 identifiers. We'll come back to that. Having LoRa 2.4 coverage in a truck or a boat is also very easy. We'll also explain in more details later on. So in the end, it's a matter of combining the right technologies and standards. So 18 months ago, the LoRa Alliance and GS1 started a cooperation to combine both standards to the benefit of the logistics industry in general. And we started by railway. This is why I started by the train delays earlier on. But it's not limited to railway, right? There are plenty of other sectors that can benefit from this combination, for instance, healthcare or logistics in general. We have, actually, when we started this cooperation, one of the reasons is because we have SNCF, the French railway company, that was already using both standards, right? GS1 and LoRaWAN. And they had their own way of doing this. They were, or they are still, very motivated by interoperability and standardization. So we are working on that at the moment. Other players like WITRAC are also using both standards in their own way, and they are also waiting for this standardization that we are working on. So I'm very happy to have these players in this panel today. I think it's very exciting and very interesting. So let me introduce them. The first speaker will be Ildiko Lieber. She's a project manager for GS1 in Europe since October of last year. Before that, she was with GS1 Hungary as a standards expert. The second speaker will be Jason Poulain. He's IoT Program Manager ITNOVEM, which is part of the SNCF group. After 7 years as a digital transformation consultant, he joined SNCF and is now in charge of sales and consulting for asset tracking and trains maintenance. And last but not least, Pep Pons is co-founder and CTO of WITRAC. They have created a full track and trace platform that generates and transforms data into competitive intelligence and insights for decision making. Last comment from my side is that we'll do the Q&A at the end of the session. As you can see, we have one presentation from each, and we'll take the questions at the end. So please keep your questions in mind, and then you will be able to come to the microphones to ask your questions. Thank you very much for your attention. And now I'm handing over to Ildiko for GS1.
So, hello and welcome everyone. It's always good to be. Can you hear me now? Oh, okay. So, hello and welcome everyone. I'm too short. Okay. Now I understand. So, it's always good to be the first one after lunch. So, please sit back and relax. It will be a very good ride. So, I'm Ildiko Lieber. And I work as a project manager for GS1 in Europe. So my first question is, have you ever heard of GS1? Yeah, I'm impressed. Thank you. So basically, lots of the times people don't really know what GS1 is. But I bet you use GS1 standards every day of your life. So just to demonstrate this, I brought a good example. So this is just a bottle of water, and you can see this barcode and a few numbers under the barcode. This is a GS1 standard. This is a product identifier with an AAN one linear barcode here. So what is GS1? So we are a neutral and non-for-profit organization. We work on developing standards and support the visibility and traceability of value chains. So we work together with all of the stakeholders. So we work together with the regulators, with the industry, with companies, and we sit down at the same table and try to, just work out some solution that could work with all of the stakeholders. We are global and local at the same time. What does that mean? GS1 is a global organization. So we have 2 global offices, one in Europe, one in the United States. But we also have local offices in more than 100 countries. So I would suggest that when you go back to your country, just look up if you have a GS1 office in your own country. And I bet you will find GS1 office in your country. Why is that important? Because we work together not just with big companies, but also with small partners. And when you have an office in your own country, it's much more easier to get into contact with your partner there and get support, get guidelines, get your questions answered by a local GS1 office with your own language. So it's basically always the same thing, speaking the same language from a different point of view. And I brought some numbers here. So we have 116 member organizations. That means the GS1 offices in countries. We have more than 2 million companies that use GS1 standards today. And well, I'm not going to read all of this stuff, but what's important that we are global and we work with all of the sectors you can see there. So we are present in not just retail, but also in transport and logistics, in healthcare, in railway industry. So we work with many, many industries at the same time. So just to say a few words about our standards, we have 3 main pillars of the standards, and these pillars are built on each other. So I'm going to present it from the first and most important one, which is identification. This is the heart and soul of GS1 standards. So when I showed you this bottle of water with the barcode on it, for many people who know GS1 standards, it's like the barcoding company. But basically, the heart and soul is not the barcode, and I'm going to tell you why in a few minutes. The heart and soul is the number below the barcode. Because when you want to create visibility in a value chain, you have to pick out all the points that you want to identify first. And barcodes are for a different reason. I'm going to share you just in a few minutes. The number you can see here is a product identifier, but we can also identify many other entities like assets, locations, and many, many more, even persons. And we have identifiers set in the standard itself. Why is it important? Because what we are looking for here is the data capture. You don't want to use this data. You don't want to record it manually by hand. You want to read it very fast and without any mistakes. And this is why you use data carriers. And it is a very important thing to understand that one identifier can go to multiple data carrier. One number can be encoded in a linear barcode, in a 2D barcode, or in an RFID tag. So these things support each other, but a little bit independent from each other. When you want to build up a supply chain with traceability, first you always have to think about the identification points and the identifiers you use there, and data carrier is just a second step. So the third pillar is, of course, it's like the roof of the building. It's when you start to share this data within the stakeholders, within the companies working on the same value chain. For this, you use the first 2 pillars together. So you identify, you just choose what kind of data carrier you will use in your processes. Then you can share this information that is captured with a scanner or with an RFID reader and use the data behind it from a database. You can use master data, which is a static data that describes an entity. It can be a product, it can be an asset, it can be a location or whatever. It can be event data when you know what is happening with your product, for example. And it can be a transactional data like ordering, invoicing, and all these data behind what is behind the activity that is happening to your asset. So now I just showed you a little bit about the GS1 standards and who GS1 is. but I am from GS1 in Europe, so I was tricky there. So what is GS1 in Europe? Basically, GS1 in Europe is a regional collaboration between European GS1 offices. We have 49 of them. And the reason we need this kind of regional collaboration because there are issues, there are challenges that can be solved or more efficient to be solved on a higher level, on a European level. Let's just say, for example, we have a regulation. This regulation will directly impact, of course, the countries and companies in the countries of the EU, but it will have an indirect impact also on companies from outside of the EU. First, the European countries, of course, but it will have an impact globally on companies. So to avoid doing the work double or 3 times or 4 times, GS1 in Europe just put together all these actors of the processes, and we work together to find a solution that can be used for all of us. So today we have more than 500,000 companies in the GS1 in Europe countries. Now, just a little bit about the GS1 and LoRa Alliance collaboration. The background is that in the railway industry, it is a very good industry to demonstrate how the standards can work, how we can benefit from using standards. What we know from the railway industry is that there are several needs there. For example, the tracking of asset life cycles, the tracking of the maintenance of the assets. There is a huge need for standardization because today we don't have standardized labels, we don't have a common language in this sector, but there isn't a big need for that. And there is also a big need for the visibility of the whole supply chain, because if you just think about the railway, every country in Europe has their own national railway services. But when we talking about railway in operation, of course it's cross-border. So every train crosses the border and then it enters a different system, a system of a different country. And it is very important to understand, to create this interoperability between the systems. So in 2020, GS1 in Europe and LoRa Alliance signed an MOU, a Memorandum of Understanding. And the main goal here is that we have very good experts on GS1 standards. They have very good experts on LoRa stuff, on LoRaWAN networks. And we combine these together and just put together all of our knowledge to create something bigger. So what we do in practice is basically we have a task force where we work together and try to set a document with best practices and good examples, how to combine GS1 standards with LoRaWAN network. And we are also always looking for new use cases, because this can really demonstrate how to use a standardized language and what are the advantages of using standards. And for the pilots, there's a little bit of background also for that. GS1 has a very good relationship with the railway industry because they use GS1 standards. They have need for using IoT, need for using standards for asset maintenance, vehicle traceability, and stuff like that. So it is a very traditionally good relationship between the railway industry and GS1. And what we see is that this is a very good industry, a very good sector to show how beneficial can be combining what LoRaWAN can provide and what GS1 can provide. So I'm going to finish my presentation here and give back the floor to Pierre. And please stay with us because more use cases are coming.
Yeah, I don't know if this mic is working.
No.
It's just for the transition. Thank you very much, Ildiko, for the presentation. And you made already the transition to SNCF, because the next speaker is Jason from SNCF, who will explain more about what we are doing. Jason?
Yes, good afternoon, everyone. Up. Not working. It's a mystery. I can't switch slides, unfortunately.
Something happened with the...
Yeah. Okay, sorry. I'm going to present myself. So, Jason Poulain, I'm working at SNCF as an IoT Program Manager. What we are going to talk about today is, well, the partnership between SNCF, GS1 and LoRa, the LoRa Alliance. Yeah, thank you. Why? What are we talking about? Okay, we are going to give you some figures. I'm going to give you some figures, some use cases. What's going on today? We have an ongoing deployment of IoT and also of GS1 identification. The combination of the two and some perspectives. So first, so why such a partnership between SNCF, GS1 and the LoRa Alliance? So Ildiko talked about it. SNCF chose the GS1 standard decades ago. It is currently being implemented on trains and repairable parts of equipment. So I'm going to talk about those two types of assets today. There are other assets at SNCF. I didn't talk about it, but SNCF is the French railway company, just so everyone knows. We are putting RFID tags and data matrices on those assets to identify them. Well, once they are identified, how do we get the data inside our IT systems? Well, we have two options, very classical. The wired connectivity, which is reliable, fast, but can cost a lot and is not always implementable on some sites, all right? And we have the wireless connectivity that we can deploy anywhere. That is often cheap, but we have issues with energy consumption. We have to use operators or deploy the infrastructure ourselves. And for IoT use cases, we tend to use wireless connectivity. And for that, LoRaWAN has the best trade-offs for us. So we mainly use that connectivity for our IoT use cases. Well, to start GS1 at SNCF, what are we talking about? You have to understand that we started with a variety of tags and identification systems on trains and on parts. You can have several identification systems on one asset because you have several entities working on them. So we had to go towards a standard, and the standard is GS1 using RFID tags mainly on trains and data matrices or RFID tags on equipment parts. And the benefits, well, for the trains, for instance, we can identify them easily. And to take an example, associate maintenance operation made on maintenance centers to a train directly, automatically, without having to do a manual operation. And this improves reliability and, of course, productivity, which is a key objective for us. For parts, for instance, we have developed an application that enables SNCF operators to scan a part and to have a unique identification card of the part with all the relevant links to the IT system. So, of course, we still gain time and productivity. I told you it was an ongoing deployment, so we do not aim to equip all trains and all repairable parts. All right, we do it when we have use cases. And for trains, for instance, all the high-speed trains, the TGVs are equipped because there was a need to have the information about maintenance in maintenance centers. For parts, I have another use case for some regional trains. All right, we wanted to identify the graffitis on the trains. All right, the area of the graffitis to be able to order the services to clean those, and we had to add RFID tags to associate the images taken to the train. All right, and for parts, it's the case also. So we're going to we have a huge variety of parts, around 20,000. We're going to equip less than 10% of those, and we focus on the high value ones. So for instance, when we have to follow what we call the configuration of a part, meaning where we install it inside the train, right? While digitalizing and adding a GS1 identifier is really useful because we make fewer mistakes, really a lot less. And also, when you have two parts that are really similar, it's really useful to have an identifier because if you mistake one part for the other, you can really stop production because you cannot use the wrong part to install in a train. So really, those use cases are important for us, and here the identification provides a lot of value. I'm going to make a small introduction about IoT at SNCF. We have around 20,000 devices, IoT devices, all right? We use them to improve industrial performance, meaning we improve maintenance of rolling stock and robustness of the infrastructure. And this enables us to reach three key objectives for us, all right? Regularity. If you link it to IoT, well, you add a tag to a train, you can follow it at each step, okay, maintenance center, railway station, and so on. And so you can identify where delays happened and what you can do about it. User comfort, think temperature devices to measure temperature inside trains for all trains, and environmental protection when you measure energy consumption using IoT. Use cases combining LoRaWAN and GS1 are emerging. I have two examples for you. The first one is the DDA box, which is an SNCF device that captures the RFID tags on trains and transmits the information through LoRaWAN to regulators, train operators, and so on, depending on the needs. The benefits are reliability and anticipation. And another one really different is connected scales. We are experimenting inside the maintenance center. All right, so the scales enable us to know how many parts we have by weighting them. And the scales are associated to a GS1 identifier of the parts, and the information is received through LoRa also. And here the gains for us are less need to do inventory manually, gains of quality, and so on. Some perspectives for us, what we are currently doing in terms of IoT, GS1, and LoRa. So we are working on defining a private LoRa offer. The two key benefits for us in terms of business case, right, optimizing costs, and because it enables us to install gateways inside trains. And we have some use cases, all the use cases for what we call telediagnostic that rely on those gateways. I talked about maintenance centers, so that's the centers where trains are maintained. We have more and more IoT use cases there, for instance, identifying trains, energy consumption, tracking assets, tools, and so on the maintenance centers. So it's gaining traction. The issue there is the business case has to be really strong. We have some issues of budget. IoT is not really cheap, so we are working towards more and more use cases there. Another perspective is that we have LoRa, but we are also exploring other connectivities like 5G and what use cases we can develop with that, and so on. And 5G RedCap when it comes. And also, I told you about identifying trains for maintenance centers. So we are really deploying a lot of RFID boxes and readers to catch trains when they enter maintenance centers and when they go back to the commercial rail network. So yeah, that's it for SNCF perspectives, and maybe Pierre can give you the...
Thank you, Jason, for the presentation. Very interesting. Thank you for mentioning the concrete use cases. I'm sure it will raise questions afterwards. So After trains, we will now move to boats, and WITRAC, who will explain one of his use cases with boats.
Thank you, Pierre. Hi, my name is Pep. I'm the CTO and co-founder of WITRAC, and I will explain how we prevent the loss of perishable goods, medicines, vaccines using LoRaWAN and GS1 standards in the cold chain asset tracking. First, we'll explain the problem and the main technical challenges. We will continue presenting some insights of the use case and the environmental impact, also very important. And I will finally deep on the technological architecture of the solution, and I will present also some LoRa 2.4 GHz advantages. Maintaining the correct temperature of perishable goods and medicines is one of the biggest challenges nowadays in the entire supply chain. Any deviation of the temperature means a lack of quality on the product, and the complete chain of custody is totally broken. So the replacing traditional manual processes with IoT platform is fundamental for the monitoring of the goods. But to ensure the safety of goods, the continuous monitoring is totally required, and it was a real challenge until now. We solved that challenge, that industrial challenge, providing complete visibility of international maritime transport containers with a combination of multi-protocol LoRaWAN, cellular communication that transmits the critical data of the maritime containers, leveraging the long range of LoRaWAN, and also the worldwide harmonization of LoRa 2.5 GHz. All the data is real-time transmitted to the cloud platform using satellite communication, as we will see later. And of course, GS1 standards are essential due to the big quantity of agents throughout the supply chain. Now I will give you some insights on the use case. Boluda, Corporación Marítima, is one big maritime global agent, and they had a very big issue with cold chain transport during the last COVID crisis, because they were responsible for the delivery of vaccines between Spain and Canary Islands. They are also offering now a daily service of cold chain transport between Spain and the Canary Islands called Daily Canarias. We are now indeed with 10 ships being completely monitored with LoRaWAN communication, as we will see later in the platform architecture. Previously, Boluda had to wait until the container arrived to the destination port to detect any kind of temperature or operation parameters of the container malfunction and the damage caused. Now, with our tracking technology in every maritime container, they can monitor all the condition of the refrigerated container, all the temperatures, and detect any kind of malfunction as soon as possible, so that the crew in the ship can act before the perishable goods or medicines are lost. Regarding the environmental impact, we managed 5% of CO2 reduction of fuel and emissions, thanks to the improvement of the transport efficiency, both in maritime and truck transports. We calculate the optimal speed of the ship and the optimal route of the vessel so that it arrives on time with the less power consumption and CO2 emissions. During last year, we managed a reduction of more than 10,000 tons of CO2. We also managed a reduction of 80% of refrigerated food waste, also with the monitoring of temperatures and the refrigerating equipment status. And this means more than 25,000 tons of reduction in CO2 during the last year. Here we have the solution architecture. We have three main building blocks: the infrastructure, which is the hardware, the WITRAC core, which is the backend, and the management and visualization platform, which is the frontend. Regarding the infrastructure, we have our WITRACker product. It is a geolocation device that unifies three different location protocols: GPS, Wi-Fi positioning system, and cellular location. And it can transmit this information using both LoRaWAN and cellular communication protocols. When the refrigerated containers are in the ships, they communicate through the satellite LoRaWAN gateway that's installed in the tower of the ship. And when the containers are in a truck or in train for intermodal transport, they communicate with cellular connectivity. So they have end-to-end connectivity worldwide. Of course, we tested both LoRaWAN sub-GHz and LoRa 2.4 frequencies, and we managed to communicate the data from the deepest holes of the ships, and even from inside of the refrigerated metal containers. Even our devices are able to control the operation parameters of the refrigerated container. For example, they can change the temperature, or they can turn on and off the controller of the cooling equipment, and they can monitor all the set point temperatures, supply temperatures, return temperatures, because we connect with a serial port to the controller of the equipment. Regarding the backend, where all the algorithms are applied and this data is transformed into value, we have first the location engine, which aggregates all the data of these three positioning protocols: GPS, Wi-Fi positioning system, and cellular positioning system, together with other sources of information such as maritime location services, such as AIS. Next, the business rules module integrates all the data and calculates journey times, point of origin, point of destination, time spent in the ports, and of course, the cold chain rules that are sent directly to the crew in the ship so that they can prevent this food loss. These alerts are calculated in the cloud, but they come back through the cellular communication to the ship so that everything is detected real time, because without the real time, we couldn't do this kind of control. And the crew in the ship can correct that, both all the alerts regarding the cold chain and the alerts regarding the route efficiency, both for position and the speed. And finally, we have the management and visualization platform that allows all the crew and all the customers to access to the visual data and control all the parameters of the infrastructure and the backend. They can also see the theoretical routes and compare them to the real routes of the ships. And they can also access to the KPIs dashboard in order to improve the operational efficiency. These KPIs give to the customer the necessary insights for the decision making. And the next natural step will be that this decision making will be done automatically by the algorithms, by the backend, so that the crew of the ship will even not need to interfere with the containers, because our devices are able to change the parameters and to reset the containers so that everything works with no kind of supervision. And finally, I will comment some LoRa 2.4 advantages that we learned during this project and during other projects that we did. First is the high data rate. With LoRa 2.4, we can send raw data of high rate accelerometers, RFID readers for the asset tracking that can read hundreds of RFID tags per second, and sub-gigahertz communication is not able to send all this data in real time. Long range, besides line of sight communication of LoRa 2 GHz is worse than 2.4. In environments such as metal containers or industrial, where there are a lot of big metal parts and interferences, LoRa 2.4 outperforms LoRa 868. So in these kind of use cases, the first technology is LoRa 2.4. And of course, worldwide harmonization in these shipping projects of maritime containers. Worldwide harmonization is fundamental, and also from the cost point of view, it is cheaper for the hardware and also for the monthly recurrent fee. And now, to conclude, we will present a video that we created during the last month. Hope you enjoy.
Maintaining the required temperature of perishable goods throughout the entire supply chain is one of the biggest and most common cold chain challenges. WITRAC has developed an end-to-end track and trace platform that ensures the safety of goods by continuously monitoring the location and temperature of assets through the entire chain of custody, from processing and production to storage and delivery, including maritime transport. Pep Pons, CTO of WITRAC, says the role of Semtech was fundamental to the success of WITRAC in building a future-proof product. With its help, we reduced our time to market to months instead of years, which is amazing considering the magnitude of this use case. The WITRAC Track and Trace Intelligent Platform has 3 building blocks. The first is infrastructure. It includes the WITRACKER, a geo-positioning device with sensors to confirm power supply and the ability to capture the exact temperature inside a refrigerated reefer. When the freight containers are traveling on a vessel overseas, the devices can communicate critical data by leveraging the long-range, low-power capabilities of LoRaWAN networks and the global reach of LoRa 2.4 GHz. The data is replicated in real time to a cloud server using satellite communications. The second building block is the WITRAC core, where the data is transformed into actionable intelligence. The business rules module inside WITRAC core calculates port of origin, port of destination, journey times, time spent on ships and ports, and of course, control of the cold chain temperatures. Finally, the visualization and configuration platform provides real-time information to WITRAC's cloud-responsive web platform, accessible from any device on board the ship or on shore. Boluda Shipping selected WITRAC's platform to monitor and ensure quality of cold chain transport for Boluda's new Daily Canaries line, which provides citizens of the Canary Islands with the first daily transportation of goods from the Spanish mainland. Gorka Carrillo, CEO of Boluda Shipping, says, for the first time, customers such as supermarkets, pharmacies, hotels, and resorts are receiving a daily supply of fresh foods and medicine. This has completely transformed trade logistics for the Canary Islands. With WITRAC's tracking technology, Boluda can regulate the temperature of each metal container stacked on board its ships, even in the middle of the ocean, and pass that information along to its customers. WITRAC's interoperable platform can be utilized by third-party business partners that want to develop their own solutions. WITRAC offers a suite of tools for track and trace within one unique platform to locate, monitor, and control any type of physical asset, wirelessly and in real time, anywhere in the world. Visit semtech.com/LoRa to learn more about LoRa Smart Supply Chain Solutions.
Thank you, and I give the word to Pierre.
Yeah, thank you very much, Pep, for this presentation. So we still have a few minutes for questions and answers. Maybe just jumping on the last topic, I will start by asking Pep, would you like the Alliance to work on LoRa 2.4?
Sure, of course. LoRa 2.4, as we have seen, outperforms in shipping solutions, LoRa sub-gigahertz, and there is no point at waiting until this becomes a standard. So, sure.
Okay, so we'll take that to the technical committee tomorrow, and hopefully we'll progress on that. Maybe a question for you, Jason. You mentioned private networks, public networks in your presentation. What are the criteria you are using at SNCF to choose between both options?
Thank you, Pierre. Yes, so I told you about in the perspective that we are working on a private offer. The idea is that when we have a lot of IoT devices, it is economically viable to deploy the gateways ourselves. But we have use cases like along railways where it's not I'd say efficient to install a gateway ourselves. So we work with operators and like Orange, for instance, because well, it has to be done that way. We cannot deploy gateways all across France. So it really depends on the use case. We evaluate public versus private, well, we are currently reinforcing our private offer so that we can have a whole SNCF network, LoRa network available. I hope it answers your questions.
Yeah, I think it's clear, but maybe you will have more questions later on. Just before that, maybe Ildiko, one question for you. We saw that what we are doing between LoRa Alliance and GS1 is quite generic, right? Once we will have these recommendations to combine both standards, it can be applied to any sector that you are active in. But how GS1 is helping the different sectors?
Yeah, well, basically, when you develop a standard, it has to be sector agnostic. So we provide our solution and support as a generic rule, but we also know when we are in contact with the companies that they have specific needs. So where we can help them in their sector-specific needs is that we have working groups which provide guidelines and all guidelines for with sector-specific use cases and examples for more better understanding of the standards. And of course, these working groups are open, so we have a standardized standard development process, and every company is feel free to join us there. These working groups can be companies from all over the sectors can participate in generic working groups and also in sector-specific working groups who are working on specific use cases and examples and guidelines.
Thank you, Ildiko. So we are more or less at the end of the time, but if there are a few questions from the room, we will take the time to answer them. Yeah, please. What I will ask you is to go to the microphone so that people in the back can hear you.
Hi, everyone. Eric Tag from My Devices. I know that there is the identifier things at the GS1, but there are also software pieces and architecture. And it didn't mention things like the EPCIS. So Pep mentioned the APC reader, but do you use the EPCIS as well at WITRAC, as SNCF? And does it sit into the MOU? from LoRaWAN and GS1?
Yes, thank you for the question. I don't know if you are targeting one of us in particular, so I will start, and then if you want to add some more details, feel free. The short answer is yes, it's part of the next steps. We haven't mentioned all the details here because of time, but yes, definitely we start with a simple use case, but EPCIS is definitely part of the next steps that we are targeting, to have some kind of interaction between LoRaWAN transmissions, right? LoRaWAN messages and the events that are in EPCIS. If you want to add something, don't hesitate.
Yeah, basically, I can just repeat what Pierre said, that yes, EPCIS is a standardized way of data transmission, and it can be used with multiple data carrier types. So yes, I would suggest to get into contact with the GS1 experts on EPCIS for more details, because now we don't have time to talk about everything. Okay. But yeah, the answer is a big yes.
And so from Pep and Jason, are you using it?
Yep, we are just collaborating with them for the product point of view. Yeah.
And we are participating in the working groups. I have no technical details for you today, but it's ongoing. Yeah, working with both organizations on the MOU. Yeah.
Great, thank you.
Thank you.
Any other question from the room? Seems not. So, oh, sorry, you're in the light, so please go to the microphone as well.
Hello, my name is Sian from AI Foresight from Finland. I have a question to Pep. Thank you for the very interesting presentation, and I want to ask about this LoRa 2.4 gigahertz. So as the range is long, like the ability to penetrate for the higher frequency, was that or apparently that wasn't a problem, but can you address like the challenges that could there be, like the applications which uses the existing or the old frequencies, and then the new higher frequency, but then the penetration, can that become a problem in certain applications?
Yeah.
Thank you.
For line of sight communication, sub-gigahertz outperforms. We use that in some use cases, but where there is a high concentration of metals, for example, in industrial plants where there are a lot of gates and metal structures, and also in maritime containers where there is high concentration and small spaces, air spaces between metal, LoRa 2.4 propagates better than 868 or 915. So we demonstrated that in these huge ships with a lot of stacks of metal containers, and we managed to communicate with one single gateway from the deepest holes of the ships with metal enclosures and with a lot of margin to achieve the same results with even bigger vessels.
Okay. Well, thank you.
Thank you.